Let us start exercise 6C of ICSE Class 10th Mathematics. Question number 1. If x upon a equal to y upon b equal to z upon c, so that x cube upon a cube minus y cube upon b cube plus z cube upon c cube is equal to x into y into z upon a into b into c. We just suppose it that x by a, y by b and z by c is equal to k. So here you see x is equal to ak. Just cross multiply x by a equal to k. So x will be equal to ak, y will be equal to bk and z will be equal to ck. Now substitute the value of x cube. You write down a cube, a into k whole raised to power 3 upon a cube minus bk. What is b? That is y cube. Y cube, in place of y cube I have written bk in bracket whole raised to power 3 divided by b cube plus z cube. In z, for z I have written z is equal to ck, that is ck into bracket, in bracket, and write down the power 3. So here if you see that a cube and a cube will be cancelled, here b and b cube will be cancelled, c and c cube and c cube will be cancelled. So we are left k cube minus k cube plus k cube. So we are left only k cube, that is k into k into k. So k is equal to what? K is equal to, you see, x upon a, y upon b, z upon c. So for every k you just substitute x by a, y by b, z by c. So we will get the result and it will be equal to x, y, z upon a, b, c. That will be the solution or proof. Now second part. A square x square plus b square y square plus c square z square whole upon a cube x plus b cube y plus c cube z whole raised to power 3 by 2 equal to xyz, root of xyz upon abc. Here the left hand side I have taken first, you see. I have written a square as it is. For x I have written in bracket ak whole square. I have written b square as it is. Here for y I have written what is called b is equal to bk. bk in bracket and raised to power 2 plus c square as it is, c square as it is. For z I have written ck whole raised to power 2 whole upon a cube upon ak. You see, x in place of x I have written ak. B cube as it is. In place of y I have written bk plus c cube as it is. In place of z I have written ck. So you see, taking the k square outside common, so inside the bracket you are left with a to power 4 plus b raised to power 4 plus c raised to power 4. Or from the denominator you can take k common So I have written here k common and k square upper. In the numerator part k square and k is here. So k square and k you will cancel and you will get k in the numerator part. You see in bracket a raised to power 4, b raised to power 4 plus c raised to power 4 whole divided by a raised to power 4 plus b raised to power 4, c raised to power 4, and it will be cancelled. So ultimately k raised to power 3 by 2 will get k raised to power 3 by 2. So I have written here k cube. K cube whole raised to power 1 by 2. So what is k cube? It is equal to x by a into y by b into z by c whole raised to power 1 by 2. So I have written in the roots of x, y, z upon a, b, c. This is the right hand side and hence it is proved. Now proceed to the third part of the question number 1. You see xz plus ac upon xz minus ac equal to yz plus bc upon yz minus bc. Here apply componendo and dividendo. We have xz plus ac, this is the numerator, plus denominator, you see xz minus ac, this is the denominator part, whole upon numerator as it is xz plus ac minus denominator, that is xz plus ac, will be equal to yz bc, this is the denominator part, yz plus bc as it is, plus yz minus bc whole upon numerator, you see yz plus bc minus denominator, so yz minus yz plus bc. So here you see ac and this ac will be cancelled because the signs are different. Similarly here xz and minus xz will be cancelled. On the right hand side you see plus bc and minus bc will be cancelled, and in the denominator part yz minus yz will be cancelled. So we are left here twice of xz upon twice of ac. So 2 and 2 will be cancelled. Here 2yz upon 2bc, that 2 and 2 will be cancelled. Now you see the z on the numerator part, z on the left hand side and z on the right hand side, so z and z will also be cancelled. In the denominator part you see c, and in the right hand side denominator part c. This c and c will be cancelled and z will be cancelled. So we are left with x upon a is equal to y upon b and equal to k. Hence proved left hand side is equal to right hand side. X upon a is equal to y upon b. Now proceed to the question number 2. If a by b is equal to c by d is equal to e by f, prove the following. P into a cube plus q into c cube plus r into e cube whole upon p into b cube plus q into d cube plus r into f cube is equal to a c e upon b d f. You see a upon b is equal to c upon d is equal to e upon f is given that these ratios are equal, therefore say it is equal to k. So left hand side we just proceed. In place of a I have written bk. So p into bk in bracket whole raised to power 3. Q into, in place of c I have written dk whole raised to power 3 plus r that is fk. In place of e, I have written fk whole raised to power 3 whole divided by p into b cube as it is plus q d cube as it is plus r f cube as it is. So taking k cube common in the numerator part, so k cube is just outside of the bracket. Inside the bracket what we are getting, that pbq plus qdq plus rfq whole upon pbq plus qdq plus rfq. This bracket and this bracket both are the same, so it will be cancelled and we are left with k cube. So k into k into k, again I have written here. In place of k, I have written 1 upon a upon b, c upon d and e upon f. So it was to be proved. Now proceed to the second part, that is root of a raised to power 4 plus c raised to power 4 upon b raised to power 4 plus d raised to power 4 whole raised to power 1 by 2, or is root of that, you can say. So we have to prove that right hand side, that is pa square plus qc square upon pb square plus qd square. You see, a by b is equal to c by d is equal to e by f. Say it is equal to k, therefore a will be equal to bk, c will be equal to dk. So in place of a, we have to write bk. So you see, here a raised to power 4, so that is why I have written b raised to power 4, k raised to power 4 upon b raised to power 4 plus d raised to power 4, k raised to power 4 upon d raised to power 4. You see, you take out, you see the k raised to power 4 will be taken common from the numerator part, but there is a square root. So k raised to power 4, square root of k raised to power 4 will be k square. I have written here k square. So inside the root, we are left with b raised to power 4 plus d raised to power 4 whole divided by b raised to power 4 plus d raised to power 4. And this numerator and denominator will cancel each other. We are left with only k square on the left hand side, k square. Now for the right hand side, we have to proceed like this. You see, p as it is. For a square, I have written b square k square. Q as it is. For c, I have written d square k square whole upon pb square plus qd square. Take out the k square common from the numerator part, from here and here. We are left with pb square plus qd square inside the bracket, and in denominator it is already there that pb square plus qd square. So the numerator part and denominator part, which is written in the bracket, will be cancelled and we are left with k square. That is, on the right hand side again we are getting k square. So left hand side k square and right hand side both are the same, hence proved. Now proceed to the question number 3. If A, B, C are in continued proportion, prove that. So what do you mean by A, B, C are in continued proportion? In our previous exercise we have done it, continued proportion questions. So A upon B will be equal to B upon C, that is equal to B square will be equal to AC. So either you can say B will be equal to root of AC, or A upon B is equal to B upon C is equal to K. So A will be equal to BK and B will be equal to CK. A will be equal to CK. You see, in place of B, I have written CK into K. So A will be ultimately equal to CK square and B will be equal to CK. So wherever we are getting any B square or C square or K square, accordingly we have to write it. So you see here, the first question is A plus B plus C. In one bracket, bracket closed. In the second bracket, there is A minus B plus C. We have to prove that it is equal to A square plus B square plus C square. So here I have written A, that is CK square. You see, A is equal to CK square, B CK, and C is equal to C. Each and every term has been converted or represented in the form of C. B is equal to CK and A is equal to CK square. I have written here in place of A, that is CK square. For B, I have written CK, C as it is C. So for A again, the CK square minus CK plus C. On the right hand side, side by side, A square, I have written CK square का whole square. For B square, I have written CK in bracket whole square, C square as it is. So let us proceed from the left hand side. First, take out the C square common. You see, from here we will get C, C, C. So from all these three terms we will get C. From here also C, C, C. So the C and C will be multiplied, that will be C square. Inside the bracket you will get K square plus K plus 1. K square minus K plus 1. You see on the right hand side also you see that C square again, C square again. So we have taken C square common. Inside the bracket you see the K square is there. K square whole raised to power square. Therefore it will be K raised to power 4. Here K square. Here it is, there is no any K. So 1 I have written here. So you see it's the C square. Inside the bracket K square plus K plus 1. K square minus K plus 1 is equal to C square in bracket K raised to power 4 plus K square plus 1. You see again I have written here C square. I have taken K square plus 1. K square plus 1 and just I have written here plus K. In the second bracket I have written K square plus 1 minus K. Here you see the C square. Inside the bracket K raised to power 4 plus K square plus 1. So here you see that C square, K square plus 1 whole square means A plus B whole square. A minus A plus B, A minus B. So the K square plus 1 in bracket whole square minus K square means A square minus B square. On the right hand side we are having the C square as it is in bracket K raised to power 4 plus K square plus 1. Now open this bracket. You will get K raised to power 4, C square as it is, K raised to power 4 plus 1 plus 2K square minus K square. So this plus 2K square will be, 2 will be cancelled with the minus K square. So we are left with C square inside the bracket K raised to power 4 plus K square plus 1. So we are having C square K raised to power 4 plus K square plus 1. C square outside of the bracket K raised to power 4 plus K square plus 1. So we are having same thing on the left hand side and the right hand side also. This implies that left hand side is equal to right hand side, hence it is proved. Now proceed to the second part. A square plus B square upon B square plus C square is equal to A by C. You see, we know that B square is equal to AC because it is already given that A by B and B by C are equal, so the B square is equal to AC. So in place of b, you see I have written a square plus b square upon b square plus c square is equal to, you see I have just changed a square. In place of b square I have written ac. In the denominator part also, in place of b square I have written ac plus c square. Take out a common from the numerator part and c common from the denominator part. So inside the bracket we are left with a plus c, and in the denominator also a plus c. So this bracket will be cancelled. We are left with a upon c. Hence it is proved. Now the third part, that is a cube plus b cube plus c cube whole upon a square into b square into c square is equal to 1 upon a cube plus 1 upon b cube plus 1 upon c cube. We have to prove it. So you see, first I have divided every terms of the numerator by its denominator. So a cube is divided by a square into b square plus into c square plus b cube divided by a square, b square and c square plus c cube divided by a square, b square, c square. You see here, this a square will be cancelled by a cube. So the 3 means the power will be cancelled only, and a square from the denominator part, and it is in the product form. So we are left with a upon b square c square, a upon b square c square. Here again you see this b cube and b square. If you divide b cube by b square, you will get b. So b by a square c square. In the third term, you see the c cube has been divided by c square. So we are having the c only, that is c upon a square b square. Now you see this b square can be expressed in the form of ac. So this a upon ac into c square. So a and a will be cancelled, and we are left with 1 upon c into c square. Here also you see b upon b square. You see, this is a square c square, that is b square whole square. Because ac is equal to b square, so it is in square form. So the b square whole square, it will become b raised to power 4. So b upon b raised to power 4. Here you see the c upon a square into ac. So c and c will be cancelled. We are having a raised to power 3. So 1 upon c cube plus b upon b raised to power 4. After cancelling, you will get 1 upon b cube plus 1 upon a cube. You see, again I have written here 1 upon a cube plus 1 upon b cube plus 1 upon c cube. That is the right hand side, and hence it is proved. Now question number 4. If a, b, c, d are in continued proportion, prove that. Before proving, let me elaborate these things. A upon b is equal to b upon c is equal to c upon d is equal to k. A is equal to bk, b is equal to ck, c is equal to dk. Now again, therefore the b will be equal to ck. Here you see b is equal to ck. This in place of c I have written dk. So after multiplying we will get dk square, means b is equal to dk square, and a is equal to bk and b is equal to dk square into k. So ultimately a will be equal to dk cube. So for calculation purpose, you have to remember for the time being that c is equal to dk, B will be equal to dk square and A will be equal to dk cube. So in first question you see B minus C whole square plus C minus A whole square plus D minus B whole square is equal to A minus D whole square. We have to prove it. The left hand side is equal to right hand side. Now you see here, I have opened this B minus C whole square. In place of B, I have written dk square minus dk square. Sorry, minus dk. In place of C, I have written dk whole raised to power 2. So dk square minus dk whole raised to power 2. Just open this bracket, you will get d square k raised to power 4 plus d square k square minus 2 d square k cube. It is very simple, means A minus B whole square formula has been applied here. For similarly the second term I have written here, you see C minus A whole square. C minus A whole square, that will be equal to, in place of C I have written dk and in place of A I have written dk cube whole raised to power 2. So now open this bracket, you will get d square k square plus d square k raised to power 6, because dk cube, so once you will square it, it will become d square k cube minus 2d square k raised to power 4. Now the third term, that is d minus b whole square. D minus b whole square, that is d minus b. For b I have written dk square inside the bracket whole raised to power 2. So squaring, just simply squaring it, d square plus d square k raised to power 4 minus 2d square k square. So you see here d square k raised to power 4, d square k raised to power 4 plus and d square k raised to power 4, these two are the plus, and we are having minus 2d square k raised to power 4. These three will be cancelled. This plus and this minus will be cancelled. Again you see d square k square, these are the two plus sign, and we are having minus 2d square k square, so it will be also cancelled. So after cancelling and adding these, means these three terms, 1, 2, 3 terms, on adding we get d square k raised to power 6 plus d square minus 2d square k cube. You see, just to add it all these terms, you will get d square k raised to power 6, d square k raised to power 6. You see d square as it is minus 2d square k cube as it is I have written here. On the right hand side also, you just proceed a minus d whole raised to power 2. That is, for a I have to write dk cube. dk cube. You see, I have already reduced that a is equal to dk cube. So I have written dk cube minus d whole raised to power 2. So squaring it, you will get d square k raised to power 6 plus d square minus 2d square k cube. So if you just see, the left hand side and the right hand sides are the same thing, same quantities are there. Therefore, left hand side is equal to right hand side. It was to be proved. Question number 4. Second part. Root of a raised to power 5 plus b square c square plus a cube plus a cube c square whole upon b raised to power 4 into c plus d raised to power 4 plus b square c d square, and root of it should be equal to a upon d. We have to prove it. So left hand side I am proceeding.